All right, 1-8A. It's just an introduction to equation stuff. So far what we've been doing hasn't been a lot of equations. It's been a lot of expressions. Do you know the difference between an expression and an equation?
Equations is like a problem.
Yes, those. What are those?
I'm sorry.
The equal sign, right? Okay, so equations have an equal sign. Expressions do not. Expressions are just 2x plus 7 or 5x minus 6 plus 4, right? That's an expression. But when we say that equals something, now it's an equation, okay? And that's what we're going to kind of step into today. You can kind of think of an equation as a math sentence, okay? Because you're gonna see in a little while how I can take a sentence and turn it into an equation fairly simply. So think of it as a math sentence with an equal sign. Okay, that is an equation. All right, so first thing you need to know is there are equations. Some of them will be true, some of them will be false, and some of them we call open. Okay, so true, false, and open. Okay, so I'm going to show you what this looks like. A true equation is when both sides of your equation are equal. So in other words, if you get something and when you simplify it, it says, oops, that's not what I wanted. It says 13 equals 13. When you simplify it, that is a true equation, okay? A false equation is when both sides are not equal. So if I came up with 12 equals 13, that's not true, right? It doesn't equal 13. So that is a false equation. It will not work, okay? And then open is different. Open is going to contain a variable. So one or more variables, and it can be true or false. It just depends what the variable is as a number. So something like 2x plus 7 equals 15. That is an open equation because whatever we plug in for x might make it true or it might make it false, okay? So we call that open. Could go either way, true or false. Okay, so I'm going to give you just a list of equations, and you tell me, is it true, false, or open? Okay, true, false, or open. So here's our first one. Let's say I have 26 plus 5 equals 22 plus 9. That is true, right? Because 26 plus 5 is 31, and 22 plus 9 is 31. So when it I just wrote 3 though for some reason, 31. So when they equal each other, then that is a true equation. How about this one? 9 times 6 equals 54. Have I showed you the trick of 9? I feel like I did. 9 times 1, right? Here's my first finger to you guys, is 9. 9 times 2, my second finger is 18. Did I show you this? No. Oh. 9 times 3, put your third finger down, is 27. 9 times 4, put your fourth finger down, is 36. 9 times 5 is 45. So what's 9 times 6? 54. 9 times 7, 63. 9 times 8, 72. 9 times 9, 81. 9 times 10 is 9, and 0 on the other side, 90. Isn't that cool? Yeah. So 9 times 6 is 54, which means this is what? This is true. All right, what about this one? 7 times 3 equals 24. That is false. 7 times 3 is what? 21. Okay, so that's false. What about this one? 3x minus 9. I love it when you guys call it ahead of time. 3x minus 9 equals 21. That's open. Why is it open? Right. If it has a variable in it, it might be true, it might be false. We don't know. It depends on what you plug in for the variable. So it's open. Could be either one. You thought it was what? Oh, 3. Gotcha. I see what you mean. Yeah. 3x minus 9. Yeah. All right. What about this one? X plus x equals 2x. Well, be careful.
Oh, it's true.
It's true. 2x equals 2x, right? No. So if I divide by x on both sides, right, I'm left with 2 equals 2. So that is true. So don't let it deceive you that it's just if it has a variable, because it can have a variable and those variables cancel each other out and it's true. Okay? What's this one? 9 equals 5 minus 2x. That's open. Okay, that one has a variable just on the one side, so you're not going to be getting rid of anything. That is open. What's this one? Last one of these. 27 minus 3 equals 8 times 8. 27 minus 3 and 8 times 8. That's false, right? Because this is 24, this is 64. Those are not equal, so we would say that's false. Okay, everyone clear on open, close, or sorry, open, true, and false?
Yes.
Okay, there's not closed. No, I just was thinking opposites, so I went with closed. All right, so you're going to be coming up with, at times, a solution to an equation. A solution is just a value of a variable that makes your equation true, okay? So if I said something like this, example 2. Is x equals 6 a solution to 32 equals 2x plus 12, okay? I want to know, can I take this x value, plug it into my equation, and get a true equation, okay? So if I plug this in, it's going to be 32 equals 2. What operation are we doing between the 2 and the x here? We're multiplying, so 2 times 6 plus 12. What's 2 times 6 plus 12 is 24. Okay, so this is saying 24 equals 32, which it doesn't. So is x equals 6 a solution?
No.
The answer would be no. Okay, that doesn't work out. How about this one? Is m equals 1/2 a solution to 6m minus 8 equals -5? Is m equals 1/2 a solution to that? So you're just taking that m value and you're dropping it in place of the m. Again, we're multiplying, right? So it's 6 times 1/2 minus 8 equals -5. What's 6 times 1/2, or half of 6? You could write it as 0.5. Is that what you said? Yeah, so 6 times 0.5 you could do. Or half of 6 is 3. Someone else said it. 3 minus 8 is -5. So we get -5 equals -5, which is true. That works, right? So is m equals 1/2 a solution? We would say yes, that is a solution because it works out to a true equation. Okay? Good morning. No problem. Okay, last one of these. Is x x equals 5 a solution to 16 equals 4x minus 4? What do you do? You're going to plug x in as 5, right? So if we set that up, 16 equals, what operation is happening between the 4 and the x? Multiplication. So times 5 minus 4. What do you do? 4 times 5 is 20. Minus 4 is 16. So your right side equals 16, your left side equals 16. Is it a solution?
Yes.
Yes, it is. Okay, questions on that? Okay, so that is 1.8a. I'm going to give you, that's the first lesson. We have 1.8b to do.